All right, so let's do some applications. So it says a rectangle has a length of 10 centimeters and a width of 8 centimeters. So let's draw that. So we have some rectangle. And we know the length is 10 and the width is 8. So we know that. Now we're going to cut squares of 2x by 2x out of each corner. All right, well, we're cutting out these squares, and it's 2x by 2x out of each corner. Okay. And then the sides are going to be folded up to create an open box. Okay, so again, we're going to create this box. And so maybe we have something like that. Now, what are our sides and stuff like that? Well, we're folding it up, so we know that the height here is going to be 2x. Now, probably didn't draw this really to scale. This should be shorter than this, but that's okay. So our front is going to stay our front and our side is going to stay our side, even though it doesn't look the same. Now, how far is this? Well, it's going to be a total of 10, but we're subtracting off 2x here and 2x here. So this is going to be 10 minus 4x. And this is going to be 8 minus 4x as well. Okay. So that's going to be our dimensions. So now let's read some more. So we've kind of created our open box. Now this is open up here on the top. Express the volume of the box as a polynomial function in terms of x. And then we need to find the size of these squares that should be cut out to maximize the volume enclosed by the box. All right, so volume. Well, volume is length times width times height. So volume is equal to our length, where our length now is going to be 10 minus 4x. Our width is going to be 8 minus 4x. And our height is 2x. All right, so now what do we do? Well, now we have to multiply this all out. So now we're going to say, well, this is really, probably should write this as v of x, because we're taking v in terms of x since we have the x's here. So this is really v of x. If we just were doing, length times width times height, we could do v. But since this is in terms of x, we'll say v of x. And now we FOIL. So 10 times 8, so that's going to give us 80. And then 10 times the minus 4x is a minus, oh, where's the 0? Minus 40x. Then here is going to be minus 32x. Then the minus times the minus is going to be plus 16x squared. And that's all still times 2x. So now we can simplify in the middle and then times 2x. So we'll have, now if we write this in decreasing powers, this is going to be 16x squared. Then it looks like minus 72x, then plus 80, and then times again our 2x. So now we multiply. And so v of x looks like our final one is going to be 32x to the third. And 2 times that's going to be 144, so minus 144x. 2 times 80 is 16, so plus 160x, and that's squared because it's x times x. So that appears to be our volume. Now, if we went ahead of units, what is our units? It's centimeters. So this is going to be centimeters cubed because we're taking x times x times x, so it's centimeters cubed. Now, this is basically our function. That's what it said. Express the volume of the box as a polynomial function in terms of x. So that's kind of like our first part. Now it says find the size of the squares that should be cut to maximize the volume enclosed by the box. Well, what we need to do now is we need to graph this. So we could have actually done it and graphed, graphed it based on what we know how to graph. But because we're going to need to actually know what the maximum value is, it's going to do some turning around. And what do we have? Well, let's think about this. Well, we have a -4. Well, we have 32x cubed. So we know that our k is greater than 0. We know we have an odd function. And so it's going to look something like this for end behavior. And what's in here, that's what we have to do is, well, we're going to have to actually find those points. And so if we did that, let's go ahead and do a quick sketch. So here, this is going to give us, if we set that equal to 0, it's going to be a minus 10 over the -4, so it's 10 fourths, and so it's positive 10 fourths, so somewhere over here. And this is going to take this over, it's going to be a -8, so it's going to be a 2, and so it's going to be somewhere here, and then we have a 0, and we know it's going to do something like this, so it's going to kind of probably come up and down and up like that. Now let's see if that's exactly what we get or not. That was just a quick guess. Let's clear that. And so our function was 32x to the third, and then we had minus 144x squared plus 160x. Now our window, we probably should do maybe a minus let's do minus 200 to 200 based on 100 units or something like that. And then our min is going to be maybe a negative 200 to a 200, and again, maybe by 100. Okay, so yeah, it's really close in here. So probably what we need to do is we need to change our window. So let's go from maybe 0 to 200 by 50s, make it a little easier to see. And then our max, let's maybe do this by 50. And our X max, maybe we don't need to go that high. Maybe let's do by, oh, let's go to 5, maybe. I don't know. We're going to have to guess here on what things are. So, all right. So we need to go a little bit more to the left. So maybe let's go to -5 and see what we have here. All right. So does that match kind of what we had said it was going to look like? Kind of up and down and up? Yeah, kind of. All right. So what we need to do is find the max of this. And this is when we can use our calculator to tell us what is the max. And what we do is we go to second calc, and we want the maximum. So we want 4. And it's going to say, what is your left bound? Well, let's go kind of up here. Our left, because this is our max point. So let's say that's our left bound. Now we're going down again. So let's say that's our right bound. And somewhere in the middle here is going to be our max. And it's actually this. At 0.736, we're going to get a max of 52.513. Okay, so maybe 0.74 and 52.51. All right, and that's going to be our max volume at x is 0.74. So let's write all that down. All right, so max, well, maybe we should put max first. Max volume is equal to, what was it, 52.51, and that's centimeters cubed, and that was for x equals 0.74. Okay, and this is all from the calculator. And so if that's the case, we need to find the size of the squares. Well, the squares were 2x by 2x, so if we take 2 times 0.74, that's going to give us the size of our box. So it's going to be 1.48, I think, if I take that times 0.74 times 2. Yeah, 1.48. And that's going to be centimeters. And so that's going to be the box size is going to be 1.48 centimeters by 1.48 centimeters. That's going to be the size of the box that we cut out. And the max volume we already said was that value there. Okay. And so those are all the things that it's looking for here. And it doesn't say what is the max volume, but that's going to be the max volume if we cut out that size of a box based on our size of our function here for the volume of the rectangle, okay, or the box, the rectangular box, okay. So that's all we need to do for that one, I think. And does it match? We have k greater than 0. Yes. It's odd. Yes. That's our volume and our size of our box that we found using the calculator. So that all looks good. Now, what about the next one? Now we have a cylinder. Okay, what does a cylinder look like? Well, a cylinder is something like that. And it has a radius of x plus 2. All right, so I probably should have drawn this bigger, but our radius equals x plus 2 centimeters. And we have our height, it's 3 centimeters greater than our radius. So if we take x plus 2 plus 3, that's going to be x plus 5. So the height equals x plus 5 centimeters. Okay. Now, express the volume of the cylinder as a polynomial function. Well, what is the volume of the cylinder? Well, it's going to be volume is equal to, what's this area basically? Well, it's pi r squared times our height. Okay, so it's pi r squared times h. And so v of x is going to be equal to pi times r squared x plus 2 squared times our height, which is x plus 5. And so that will be our volume. Now, we could graph that again, but this one doesn't ask us to find anything. It just says express the volume as a polynomial function. And so, this is a polynomial function, but we could also go ahead and say, okay, well, let's multiply it out. So that's going to be x squared plus 4x plus 4 times x plus 5. Now we have to FOIL that, and so that's pi times, and then we have x times x squared, that's x cubed, plus 4x squared plus 4x. And what I'm going to do is I'm going to then put everything below. So it's another 5x squared, and then plus 20x, and then plus 20. And so then I have pi times x cubed plus, here we have 5 plus 4 is 9x squared plus 24x plus 20. And so now that would be my v of x is equal to this value. So that would be my final one if I wanted it as a polynomial written out in full form. If we wanted it into the factored form, then I would leave it in that. From here, I can draw the polynomial, what it would look like. Here, I could just have my function, and that would be the spread out function for that cylinder. Okay, again, depending on which way they really express it, both of those are the volume of the cylinder expressed as a polynomial function. Okay, one's just a factored form. All right, let's pause there.